Okay, so on this question, we have a big piecewise function in three pieces, and they're asking to find the values of C that make the function continuous everywhere. Well, they want A and C. They only said C up there, but they want A and C. Clearly, there's the answers. How'd they get those? Um, well, what we got to do, let's draw a little graph. It's not really totally needed, but I think it'll show you what's going on. Um, or should I do it? I just don't want to run out of room. Well, all right. So here, let me just put it over here. And where are we at? We're at 0 and 5. Okay. Um, enough for that. Okay, so let me see here. So I'm looking at the x like 0 and 5. So I was saying, okay, so here's 0 and here and 1, 2, 1, 2, 3, 4, 5. That worked perfect. All right. Okay. And let's take a look at what's happening up here. This is left of 0. Left of 0 is this function. So, okay. So whatever it's doing it left of 0, whatever. I'll just go right there. Put an open dot. That's a e to the x plus 3. It's open dot because, it's not equal to 0. And then solid dots at 0 and 5, between 0 and 5. So this one is between 0 and 5. It does this function in the middle, right? Between 0 and 5. And that's solid dots on both those. Oh, I should have left room to the right, huh? Oh, shoot. That was bad of me. All right, let me try to go. Sorry to waste your time. Let me come in here a little more quickly. Right here and right there. Here we go. Okay. 0, 1, 2, 3, 4, 5. Okay. So again, left of 0, whatever. I don't know what it's doing. It's doing whatever. Let's say. You don't have to worry about exactly what the graph looks like. Who cares? Just it does something and it comes in at 0. And then between 0 and 5, it does something else and it's solid dots. Now, how does it, could it be like solid dot here and then whatever solid dot there? No. You can't do that. Why? Because they have to match up. Well, how do we know that? It says continuous everywhere, which means you can't be going like this and then jumping down there. Continuous means you don't pick up your pen. It continues without picking up your pen. So you can't jump like that. That cannot be the case. Instead, it's got to fill in perfectly and then do whatever it does, then, well, here, I don't mean to make it seem like it's the same height. It's not necessarily the same height. Let's make something up there. It's got to fill in, it's got to match. Okay. And then the right part, this is x greater than, did it confuse you the way they wrote it? It's the same as writing that. X is on the wide side of the mouth, which means greater. So this is to the right of 5. It does that function. So to the right of 5, it does that function. And that's open dot again because there's no, it's not equal to 5. So now could it do it like down, could it do it down here and go like that? No. And it's got to match up again because it's a continuous function. So it's got to be matching up right there and then whatever after that. And that's the x squared function. I forgot to write the one in the middle. This is the cx plus 7. So they have to match up. They have to equal each other. They have to be at equal height at 0 and at 5, they have to match up. Okay, so what does that mean then? That means in particular that, let me write two equations for us. A e to the x plus 3 must equal cx plus 7, where? Right there at 0. At x equals 0. So you could plug in 0 and plug in 0, right? At x equals 0, they are equal. So what does that mean? This becomes a e to the 0 plus 3 is 0 times x plus 7. I'll keep it yellow with that orange. That helps. So it's C times 0 equals 7. In other words, that's just 7. Yeah, do you remember that? Let's try to keep changing my colors. E to the 0 is 1. Anything to the 0 power is 1. So this is A plus 3 equals 7. So we can solve for A, right? Running out of room here. Let me get some more room. So subtract 3, subtract 3. Maybe I should have kept with the color. And as we do, we're going to get A equals 4. So we got our hands on A, and sure enough, see, it's the value of A. Now, the other connection is at 5, right? At 5, we've got the yellow function right here at 5. They got to match up, so CX plus 7 has to equal x squared, where at x equals 5. They match up at x is 5. So that means you can plug in a 5 there, and you plug in a 5 there. And you get what? 5 times c plus 7 equals 5 squared. So 5c plus 7 is 25. So now we can subtract 7 to solve for c. On this one, like this, right? And we get 5c equals, these cancel, whatever that is, 18. And then divide by, there it is. C is 18/5, A is 4. And there's our answers. That's how we do it. They have to be equal at those x values because it's a continuous function. It's the meaning of being a continuous function.